Alright, what is going on? So I'm going to try to solve this problem in less than 30 minutes in real time. So this is Sudoku solver problem. So I'm going to try to solve it how I would in an interview. So this is interview practice. So what we're going to do is we're going to do approach 1. And approach 1 is going to be basically DFS plus backtrack, because I'm going to, because to solve this problem, this is the solve Sudoku, it's not the check if valid. I just did check if it's valid. Checking that you can solve it is going to have to look at the Sudoku board. It's going to have to like fill them in by doing some type of DFS search, and then once it reaches the recursion case or the end case, it's going to have to maybe backtrack if it gets stuck. Okay, so the main idea is during this process, we're going to have to check our row, our columns, and our, so it's similar to the is valid. So is valid, what I did is I checked yeah, so we want to, basically we want to add a number to the board if it is not in the row, column, or subboard, if that makes any sense. So like if a number or digit, I guess, is not in the row, column, or subboard, and for these what I'll store is basically the values as like 0, 1, and so on. And in my is valid video I went over this, so I'm not going to go too much into that. Okay, sure. So add number to board if it is not in the row, column, or subboard. If the DFS is false or it needs to backtrack, we're just going to want to remove. So let me talk about this for a minute. So basically the idea is that I'm going to use a data structure, kind of like a dictionary, to store for the rows, the indices for the rows and the columns, the number that represents the row, the column, and I have a set that contains the digits we've seen. So then the only time I want to search down a path is if there's a digit that I have not, that is not seen in any of my dictionaries. And also the subboard is going to keep track of the values that have not been seen in the as well. So that's basically all we have to do. So to be able to do this, we start with creating my rows, cause, and subs equals, okay, so I want to import from collections, import default dic, and deck. Do I want both of these? I'm going to use both of these. And so I'll say default dic, okay. So I want to fill these in. I mean, I guess I already know how to do this because I know this trick here where if you divide by 3, do floor division, it'll give you the coordinates 0, 0. It's very good to like try this out, you know. 1, 0, I guess 1, 1, and so on. That's what it'll give you, because if you take 5 divided by 3, that's equal to 1, right? So it's like, okay, we might be in the second column, and we might be in the second subboard. We have 9 subboards. If it's not any of these, add it to the empty. Well, we want to append the coordinates. I think that ought to do it. Definition DFS, create our DFS. And then at the end of this, we want to call DFS. What do we want to return? We want to return the DFS, which is going to return true or false. Okay. So, let's try in the DFS. We're going to have to implement the backtracking. So we want to get the first thing that we added to our empty deck. And we want to do we want to iterate through numbers for num in range in okay, those are the numbers we want. Okay. So we have to go through the number, and then we want to check if the number, the number is really going to be like a digit. I don't know if it matters what I put here. Yeah, it's more like a digit, I guess, because it's just, what's a digit? Yeah, a digit is a single, like 0 to 9, okay? I want to add these, well, I only want to add them if, oh, I guess if dig's not in all of these, if it's not in any of those, then you want to try this as one of your answers. And add it to everything. Because now you're no longer going to be able to use this. Then we're going to do our recursion, call DFS again. Return true if DFS returns true. If DFS returns false, okay, when do we return false? Let's say we return false whenever we go through this entire for loop. Yikes. Yeah, whenever we go through this entire for loop, and we can't put it, it's already in these hash